This conference will now be recorded.
All right. Hey, everyone. Thanks for joining the biweekly Door Heat Exchanger sub-project call. As you guys are aware, we did not meet the last time, as we didn't have too many updates, and we just wanted to give people time back to focus on the slides, which we will talk about later on the call. Before that, I'd like to just quickly go over the agenda. All right. Can everyone see my screen?
Yep. No
Yes.
problem.
All right. All right. Thank you. There are a couple of things I wanted to focus on for today. One was to just go over quick updates in the focus areas. Basically, the focus areas are everything we're going to be talking about at the Global Summit in October. And I'd like to touch on the status of draft slides, which are due at the end of next week. And then maybe there might be a good opportunity for us to discuss, after these efforts are completed, what are, some of the areas we'd like to focus on moving forward. So I think it'll be a good opportunity for the community for those on the call, basically to, propose some ideas or propose some areas for us to start working on for the next cycle. But coming back to quick updates in the focus areas, I do see Sankar on the call. Sankar, if you don't mind, maybe
Yeah, I'm here.
We could quickly talk about some updates over here.
Sure, yeah. So last time we just discussed at that time, um, we haven't started working on the presentation for the summit. And over the last 2 weeks, we started creating the presentation. Um, I have I have simulated a replacement microchannel for a ORV 3.0 rare door heat exchangers. So this heat exchanger would, I mean, of course, this is not the final design, but this is a representative design that would replace a fin and tube heat exchanger as a alternate technology for rare door heat exchangers. We will be presenting that solution, how it will look like, uh, what are the performance benefits, both from a heat transfer perspective and the pressure drop perspective, and we'll show uh, what it means to use a microchannel, how can you benefit either from a heat transfer perspective or from a lower pressure drop, how can you benefit from lower fan draw on your rack. So John, I don't know if you want me to go through the presentation or just, I don't know what, or just this is enough. Not sure.
Yeah. I think just a quick update. And I've also, Sankar, I've also taken the data that you provided, and as we discussed, based it on a 30 kilowatt load, assuming 3500 CFM. I think at 30 degrees C ambient, a 15-degree delta T across the SI delta T across the IT hardware is a pretty reasonable claim. And obviously, since you size the microchannel, which is and I should have noted this over here, which is the orange line over here. Since you sized it to be very close to the fin and tube coil, obviously the performance numbers are very close. But similar to the custom ORV3 coil that we had put together for the previous white paper, it's not surprising that it can comfortably support 27 degrees C water to create 30 degrees C air. So so I think we can sort of take this analysis and then put it into a summary. I think at that point, then we would like to talk about comparing the two solutions, right? Because it's like, okay, we have confirmation that, or basically one of the focus areas was to look at an equivalent design, right?
Hmm.
Targeted to remove 30 kilowatts of heat from IT gear in an open rack V3. And then, here are the comparison points, right? Weight,
Yep.
cost,
Hmm.
dimension, volume, right? And I think with weight, we talked about dry weight and wet weight, right? I think that
Yep.
that
Yep.
matters. So yeah.
Yeah, I'm still waiting for some information on the Finitube side.
Okay.
I mean, I could estimate based on it's a 5 row, and I think the current technology used here is a 3/8 tube Finitube. If that
Okay.
is the case, I can estimate that shouldn't be a problem. But if it is a different tube size, then I just need that information. But I
Yeah.
think
So,
most
so
probably
you're
it's a
so
3/8
sorry.
inch
So
tube.
let me help you out over here. What is the information that you're looking for from Naveen and
Uh, I mean, if they can give me the weight and the internal volume, that'll
okay,
be the best.
internal
If
volume?
not, uh, if not, the tube diameter and tube spacing and things like that. It's a 5 row, and typically it's a 1 inch by 0.866 inch heat exchanger. But if that is not the case, then I just would like to know what tube diameter and what is the tube spacings and row spacing.
Gotcha. So dry weight and internal volume. I did see your email this morning. Um,
Hmm.
so I'll follow up with uh,
Naveen and
with
Philip.
with Naveen and actually with Philip to see if
Yep.
he can push to have this information. So yeah, absolutely.
Okay. Okay.
Okay, awesome. Yeah,
Yeah.
so that effort's coming along really well. Thanks, Shankar.
No problem.
Um,
I think I'm hoping to. I mean, I have wrapped most of my part from it. I just need those couple of slides from Boyd on the context background of the of what we're talking about here. And
okay.
in that, I think we should be pretty much good. My only help I would need from you is, so this is the first time I'm pressing to OCP. So there's I just looked at the template, and there are like tons of logos in there, and there are
Oh yeah,
specifications
yeah.
on
I'll
where
take
to
care of
use what logo and things like that.
that. Yeah,
So
yeah,
I just
yeah.
need I just need that guidance. So
Yeah, absolutely. I can take care of that. Yeah, sure thing.
okay, wonderful. Yeah,
Okay.
thank you.
Okay, moving on to the modular data center and hybrid cooling effort. I don't see Carl on the call, and I know David is off, but um, effectively, we have completed the analysis. Um, um, David helped size a CDU as well as the heat rejection system, and conducted and and we have the information on partial PUEs based on Frankfurt and Dubai. That's going to be the basis of the presentation. Um, and then he also took a special approach for Dubai, where we separated the cooling requirements of GPUs and door heat exchanger. So we're currently working on the draft slides. I think that's when we can probably open this up, and everyone can have a clearer understanding of what we've done over here. And then once the draft slides are done, and Carl and I are going to work on that, then we're going to move on to the white paper draft. So we want to build the slides first. Um, because um, that will give us a good flow that we can then use for the white paper, because we want to make sure the white paper isn't too long, because that'll pose a challenge for folks to read it and truly consume it. So yeah, just quick update over there. And then moving on to frame-based deployment of door heat exchangers, I do see Jarrett on the call. Jarrett, do you want to provide a quick update?
Absolutely, yeah, I can provide an update. First, I want to say thank you to everyone who was able to share some of their door heat exchanger CAD. That has definitely been helpful in designing this frame moving forward. And so I'll definitely say if any other teams here are able to share CAD, That's definitely something I would like to talk about in regards to your door heat exchanger. Currently, we're building the frame um, to a uh, a top mount for the door. However, I saw some hinges on different doors that are on the frame itself that are further down. They're not on the top, and I've seen others that attach in different ways. So, just looking to find a standardization here. And I do have a preference, and I'll share that a little bit later. Something that I can also do is I do have some CAD um, that if the team was interested, I could show briefly just to show how it's changed a little bit if that's of interest to the team here. But I can always share later on in the process as well. There's no rush. So I guess that's a question if that's something the team would want to
Yeah,
see.
yeah, absolutely. I think let me make you presenter. Let me
Sure.
just do that.
Awesome. Let's see if it'll let me. All right. I'm gonna window here. All right. Please let me know if everyone can see the cat here.
Not yet.
Okay, so my screen's not sharing. Let me click this again. It says can't share screen. Hold on, let me try one more time. Let me try entire screen this time. Maybe it'll work better. All right, you can see my CAD now. Can you see my screen?
Yeah,
Yes.
now
Yeah, we
yes.
can see it.
Nice, nice. All right. So as I mentioned before, some different mount options. Evaluating all of them currently, but when I mean mounts, I mean of course like the hinge that is attached to the top of the door. I've seen some options that can be vertically attached this way. I've seen different vertical, mounts. I've also seen, mounts that are on the side of the door here. But what you can see is that we have, and what you don't see is that there will be flexibility on both sides for the hinge as well as the port for fluid lines to move through the frame and attach to either the facility or to any other attachments we might need. This will be paired on the opposite side, so there's flexibility for mounting depending on the vendor and the needs. Additionally, one thing I actually wanted to get some feedback on quickly was in terms of the gaskets for the door to the frame, as well as the alignment method for the rack that I've chosen here. If you look, you'll see that there's a flange that's bent outwards with a gasket on it. I do understand that if you're pushing a rack, onto this face, that you might knock this gasket off. So that is one piece of feedback I'm aware of. But I am curious about the type of gasketing that's used on the frame, and I wanted to know if any of the team here has maybe had any experience or concern with using a let me get a top view here in using this form of I guess seal and containment for the rack.
I cannot say too much about the gasket, but about the interface to the reactor. Maybe it's a good idea to keep the same interface like the Open Rack V3 because the usually the we are interested in use the reactor for OpenRAC v3, but as well for this frame. So the interfaces of OpenRAC v3 to plug the reactor will be interesting for us because in that case we will not have to change nothing in the reactor, and we can apply this reactor in the OpenRAC v3 as well as in this frame.
Understood. And I do have that reference CAD as well that you're mentioning. Who is it that just spoke now? I'm sorry.
Juan Carlos, I am Juan Carlos.
Juan Carlos. There you go. Nice to finally talk to you, man.
Yeah, yeah.
Okay, so 817. Okay, so
So I guess Jared, your question, maybe if I rephrase your question is, for door heat exchanger suppliers who, provide the solution, provide the door heat exchanger with a frame, right? Because traditionally the frame is mounted to the rack, right? This is kind of
exactly,
different. But
exactly.
the assumption would be is that that solution where the door and the frame come together to be mounted to, EI 310 racks, let's say, for example, because that's more predominant. I guess the question would be is what type of gasketing is used between the frame and the door, and then
Exactly.
potentially between the door and the rack in a more traditional case. And I guess maybe you want to know what's already been engineered or put out there, so we could potentially adopt it.
Exactly. I think a lot of the basics of the frame, I'm using, references from some of these other frame designs as well to make it as easily applicable as possible. However, there's some, just, standard parts that we want to make sure we order the right ones and use the right ones in our design. And so that's exactly the question, John, is, is there is there a standard that we're using here for a gasket in terms of like compression ratio or, you know, um, the width of the gasket or things like that, or even just the material. That's kind of what I'm curious about, if that's very specific.
Yeah, I can ask internally which kind of gasket we are using. It's not a problem. But usually the gasket is part of the rear door. Maybe we put in the rear door or in the front of the rack, but usually this gasket come with the rear door.
Right.
So yeah, in that case, maybe you don't need to put a gasket because every supplier will bring the gasket with the rear door.
Okay. So from what it sounds like you're saying, Juan Carlos, is, excuse me, if we were to, implement a gasket, it doesn't have to already be on the frame. It'll be on the door. So what we could do is maybe outline a perimeter, or rather an area of where the
Yeah,
gasket should contact, and
Yep,
then just
yep,
be
yep.
in that. Okay.
yeah,
Yeah,
yes,
and
because
then the door would have to be compliant with that contact area. Yeah.
Exactly.
yeah.
Exactly. Okay. Um,
Also, I say that because I know the problem the rear doors because if you use 19-inch tracks, you have the height is always different, the width is always different, the power is always different, the connections for the water is different, and as much as your differences are you put in there, you will or we will have to develop new rear doors and the variancy is incredible high. So to keep this interface the same like the OpenRugby 3, for example, will be very helpful because we have to develop only one reactor for OpenRugby 3 or for this frame. Also the gasket. If we bring the gasket with the reactor, we need only the surface, the contact surface, like the in the OpenRugby 3, and then we will match we will put the reactor in this frame as well as in the reactor in the same way.
Understood. Understood. All right. Thank you for that feedback, John, Juan Carlos. Um, Otherwise, the frame design here, once if I can get any more door CAD, that would just be helpful so that I can help make this frame more applicable to your specific design, for your team, company, etc. Uh, I'll just show, some of the design here. We have this bottom face, which is just going to be the guiding feature for the frame, and of course, we'll have a prototype at OCP. One last update I can give, as I just show, some of this CAD here, is that I will be able to get a manufacturing sample by the beginning of October, end of September is the timeline. I'm currently speaking with a manufacturer, and we'll be able to, bring one of these with us to OCP. And so there'll be a chance for the team to see it as well.
Okay.
All right. Those are all the updates I have here. And I'll talk to you more as well, Juan Carlos, offline when we get a chance.
Yeah. Okay. Yeah. Yeah. You can write me an email. No problem.
Awesome. Thanks. All right. Are there any questions for me before I stop sharing? All right. Thanks, everybody.
Yeah. Thanks for that update, Jared. it looks like it's coming together pretty well. So awesome.
Yep. Thanks, John.
All right, let me go back to the screen. All right, hopefully folks can see. So those were the updates in the focus areas. Moving on to the draft slides for the Global Summit. As I said previously, they're due on the 25th, which is a Friday next week. Obviously, these are draft slides, so all the material doesn't necessarily need to be in there. You can put a couple of placeholders. But yeah, I just kind of wanted to check in on a couple of areas. I know Sankar's already talked about the aluminum microchannel. That slide deck's coming along. I talked about the densifying modular data centers with hybrid cooling. I have a call with Carl next week to work on this, and we kind of discussed it this week and kind of divvied up the work. I think with regards to the frame-based deployment of door heat exchangers, Jarrett, I know you're at the DC right now, so but I did have a chat with Saket and reminded him about the deadline. So he said he's going to work on it next week, so he'll probably reach out to you about that. But the one area I did want to touch on is the door heat exchanger project updates. Jabari, I know you sent out a link earlier this week. Do you want to maybe chat about if there's any support or any information you need, or like where we're at with that?
So I've been kind of using the meeting minutes for the various work streams that we have, as well as the meeting minutes for this main project call to kind of build that. So I mean, I have a couple of slides that have been put together. I guess the two questions I have are, well, based on what you've seen, well, my intention is for each project, like for instance, the frame-based deployment or the aluminum microchannel, that I would just kind of discuss why it is we're doing that and why it is we're doing that investigation, as well as just at a high level, what are the topics that are going to be discussed in that white paper or presentation, right? And that I'm going to do the same thing for each one. Okay. My intention is also to get a couple images, because I think I have a lot of text right now. I just want to, I'll probably go through, or I'll reach out to people to find out, what images they have in there, in the documents that we've done so far, that I can just plug in, maybe one or two, to just kind of enhance the document. Sorry, I had one more question. Actually, I'll just present to show you, because it's easier, I guess, for you to.
Yeah, let me make presenter. Go ahead.
Hold on. Right. You should be seeing my screen now. So there were a couple of items in here that I wasn't sure if we needed to do updates for. So that's what I have on this slide. I'm not presenting this. It was just to ask you guys about each of these. John, I know in the last call that we had before this, that you said this was on pause. So I'm going to remove this sustainability lifecycle.
Yeah. So actually, on that, I was going to suggest that we maybe move that to like future efforts or something like
okay.
that. But yeah, because I think one thing that would be useful is not only to talk about what's ongoing and what's the mission of the sub project, but
okay.
I think it might be good to kind of tease the audience a little bit about focus areas moving forward. I think
there's a slide for that at the bottom. I just haven't gotten to it yet.
Okay, no worries. Yeah.
So, okay, but that's good to know, because I was just gonna delete it. So I'll move that down. So I am leaning towards taking this out, this concurrent maintainability discussion, because I don't know how much, I don't think it deserves a slide per se. This was, there wasn't a significant amount of like long-term involvement where we had to actually have deliverables or anything like that. So I'll take this one out.
I mean, are you going to be presenting before or after the concurrent maintainability presentation?
I have no idea. I'm not sure. I didn't check the schedule yet.
Okay, yeah, I can check that in the meantime. No worries.
What we were suggesting that if the concurrent maintainability presentation is after this that I mentioned it.
Yeah, I mean, it'll be a nice opportunity to talk about it, right? I don't see why not. It'll be
Okay.
good. It'll
Well,
be
I'll
good
mention it.
publicity. Yeah, yeah.
I'll probably move it down to somewhere near the future efforts because I can't dedicate a slide to this.
Okay, sure.
Might take too much time. The reference design, yeah. So I know we talked about this earlier in Q1 of this year, where we had EPFL case study, and then later on we had a short discussion about a vertive reference design template. I wasn't sure where this one was because I know we were kind of depending on John Gross to partner with this, and he's kind of stepped back from OCP a bit. So do we know where this reference megawatt deployment workstream is?
Benny, not to put you on the
No,
spot, but do you know
yeah,
where
no,
this is at?
yeah, no. Since our last meeting, we were supposed to meet about that, and then with John Gross, and then nothing really ever came of that. So no, we haven't gotten far at all with that, but it's still something that we could still come up with something in time. I think.
Well, I mean, it doesn't necessarily need to be in time for the global summit, but it could be, if Vertiv is still interested in contributing a reference design template of some kind, then I think, yeah, as Jabari's highlighted over here, it could be a future effort. Absolutely.
Okay. Yeah. Yeah.
Okay, no problem. So sorry, so EPFL case study, right? I know that John Manoj was kind of helping us here, right? So this one we can do future efforts, right?
Yeah.
The reference design, but the EPFL case study is that's like I think it was a Bluetooth project. I don't know.
It
Are we
was
still doing a case study on that, or is that off the table?
table.
I guess that was the
I
both
think.
on then.
I think where we had less lift, it was what was the template from which we wanted to do, because we had talked about doing a white paper, and we'd also talked about doing just a reference design or both, but we never came back and decided how we wanted to present it.
Okay, I'll bundle these then. No problem.
I think it might be good if we connect offline and figure that out.
Okay, no problem. Yeah. Okay. And then the last one was the white paper update. I know Juan Carlos spoke about it at the Prague summit, the regional summit. So I'm not sure if, and I know there haven't been any updates since then. So I'm not sure if I need to bring it up again, John.
Well, so I think the thing is that it's been contributed, right? So I think maybe that can be something that can be talked about. And now that I must confess, I know we wrapped up the document, but I was searching on the contribution portal and couldn't find it, which means that
Okay.
I probably forgot the last step, which is reaching out to Michael and saying, hey, the community has accepted this. Can you please have this published? So let me do that.
Okay.
So then for sure we can put in a QR code or something like that, and then maybe have a single slide just a just a quick summary. I think that'll work.
Okay. Okay.
Sounds good.
Yeah. Yeah, so those were just the ones I had to I wasn't clear on. But in terms of where the slides are right now, they're very in draft right now. So it was going to be a sub-project overview. I took this slide from the QR from the regional presentation that Juan Carlos did, so I'll probably modify it. This next slide was I started going through each of the work streams that we have. So heat exchange as part of the facility, just some highlights of as to what would be discussed in this document, and then why are we doing this. So a discussion of why the effort came about in the first place. And you see there like some benefits around having it decoupled from the rack, and the kind of benefits around decoupling it from the rack. And I came up with a couple on my own. Jared, I'll probably reach out. I'll send you this slide and see if you see anything else you think could be added. Or between now and when the slides have to be reviewed, because we still have to send them, we still have to get the comments from the community on the 12th or 11th of September. So between now and then, I'll probably let you guys know what the final version is. Then I went onto the aluminum microchannel. Then Saka would have covered a lot of this stuff earlier on. I'm probably gonna revise these with some of the verbiage that you have in the meeting minutes. But it's the same design of the slide, right? What the paper is or what the effort is, what are some of the benefits around doing this analysis, and why are we doing it? So how the analysis is going to be structured, or what the things are going to be covered, and why are we doing this? Why are we comparing these two in the first place? And how it's going to fit into the world of radar heat exchangers. And then finally, the modular DC. I have to work on this title. It's kind of long, so I'll fix that. But yeah, what's going to be covered, who the partnership is with, or among rather, high-level outline of what's going to be discussed, and again, why are we doing this, right? For the modular DC.
Yeah, I can help with that. I can help with that, Jabari. So yeah, I can work on this slide next week. Yeah.
Okay, no problem. You have access. I sent a Google document and a SharePoint or OneDrive document just in case Carlos.
Yep.
Okay, cool.
Yeah, I get it as well.
Okay, cool. It's just some people have issues with either Google Drive or OneDrive, so you just let me know which one is working for you. This is OneDrive I'm using right now because I can edit on my Windows computer. So,
hey Jabari, this is Jared. If you could also share it with me, I would appreciate it.
Yeah, sure, no problem. I'll send it right after this meeting. So in terms of images, you realize there weren't too many. I had one for the aluminum microchannel. I got this from the Danfoss website. So thanks, Sanka, for posting it. Just kidding. And then the image for the modular data center. So I have to figure this out, just how it looks in terms of the slide designs, and that's in the works, right? This was the last update, the door heat exchanger requirements revision. It's kind of bare bones, but I'll go through the documents and call out some specific things that we're going to change. And I'll say target date for change Q1 next year, just based on the updates that are happening in Q4 of 2023. And that's it.
Yeah, and I think, sorry, Jabari, for the requirements,
yeah,
I think if you recall, we also had a checklist, right? So I think it might be good to put a screenshot of that in there, because requirements are one thing, but if folks want to contribute their products to OCP, then they would have to walk through a checklist, right? So, and I think U Systems did that in the past with help from Mark Dancy. So,
Okay.
I'm assuming you have access to the checklist. It should be in the
I will
Dohi
look for it.
notes. But if not, send
Um,
me an email and I'll definitely find it for you.
okay, no problem.
Yeah.
The only checklist I use is the OCP ready data center facility. Once I have to go, I'll check. If not, I'll email you.
Yeah, it was basically a checklist based on the requirements, and I think we had made some adjustments based on feedback from ACF, right, where they were saying, hey, the door should be capable of supporting, um, like 10 bar under normal conditions and then 30 bar under abnormal conditions. So there are a bunch
Yeah.
of things that were discussed with John Gross, and like what sort of what sort of standard should we follow, all that kind of stuff. So there have been some updates, and I think that can factor into the Rev 2. But yeah.
Okay, no problem. But you agree with the Q1 mentioning this or not?
Yeah, I think Q1 should be fine. Yeah.
Okay. That's it basically. I have to do the future efforts and the call to action, and that's it. I think it's 4, right?
So
Sorry. What am I
so
putting here? I'm not sure for this this symbol at the bottom right.
things should be fine because maybe Juan Carlos can confirm if Rital is a platinum member. So then that would definitely help.
Okay.
Yeah,
All right.
yeah,
I'll
I
use
think
details.
so.
Yeah.
Okay, cool.
And it's the draft. Don't worry, we'll figure things out.
Okay.
Yeah.
All right.
So I do have so Jabari, related to that, with regards to future efforts, I know Juan Carlos had brought something up before, but I think this might be a good opportunity to kind of ask folks on the call, like, what are some thoughts, right, with regards to, in terms of what would be beneficial, not only to those who attend the calls, but also the general community. And I think we can use maybe like 5 to 10 minutes towards, like, at the end of this call, which is pretty soon,
No, yeah.
kind of talk about that. So does anyone have any thoughts? Juan Carlos, I know you had brought up the using the door heat exchanger, with the CDU, with cold plates, and how that potentially impacts how you do your calculations or your sizing or your controls and stuff like that. I think that was one topic you had brought up before. So maybe that could be one item to focus on moving forward. But I just wanted to also ask the community in general, is like, what gaps do you all see, or like what efforts would be truly valuable moving forward? So I think now would be a good opportunity to at least get a rough list down as part of the draft. And then we can continue chatting about this and start formalizing some work streams.
Hi, John. We spoke about the interfaces between the rear door and the CDU or the manifolds and so on. Because until now there is nothing. The suppliers will do the best for sure, but maybe we could work in that way to do something like nice to have or unstandard. I don't know. But how to connect the rear door, in which point we connect the rear door with the manifolds, with the CDU, on maybe it could be interesting part.
I actually kind of agree with that. Just based on the open TCS push that we've been getting over the last month from the ACF community to kind of standardize, in particular, the pipe routes and pipe connections, pipe fittings, and all that, and the valving that would go between the door heat exchanger and the CDU or the manifold. And perhaps the effort that we can have is maybe we could use as a guide topics that they want to cover, but I guess the complexities that are very common for different door heat exchanger projects. So like Juan Carlos mentioned, the manifold, and earlier on you mentioned flow rates and pipe size. So I guess we can make suggestions. Now I don't know if it's going to be a specification or a requirements document. I don't know how far along that would need to go. But I guess John, you could kind of you could explain where you think in terms of the type of document where this could fit in.
Well, I think we can figure out the type of document later. I think the interfaces and sizing, I think that's a good topic. Certainly because there's a lot of other liquid cooling efforts in, as part of OCP, specifically OpenRack v3 that are also nearing completion. So I think it might be good to be like, okay, if you wanted to adopt those, but also do a door heat exchanger, then this is how you'd go about doing it. So yeah, I think there's definitely value in that for sure. So I guess we would call that like interfaces and I guess interfaces definition and sizing of interfaces, right, in a sense, to adopt.
Also the connections points, you can connect the reactor from outside, from inside, and in that way and the other way, and there are too many possibilities, and depending how you are doing that, everything will be compatible or not, and this is the question. And interfaces, I mean the fluid interfaces, how to connect the fluid in the traditional reactor, but also in the hybrid or air assisted, but as well the electrical connections, how to manage the cabling, because this is an important issue, how to connect the DC bus bar to the reactor if you want to connect with 48 volts, or with AC power, which route should be get the cabling, because maybe you cannot mix some cables with low voltage and high voltage. I don't know. There are some questions here, and maybe we can yeah, put some ideas together to use it in a proper way.
Yeah, I think that makes sense. We can do that. Yeah, I think one thing that would be helpful for Jabari is to Juan Carlos, if you can maybe help summarize that in terms of what would be the title of that effort, and maybe some high level bullet points. I think that would be super helpful. I don't know,
Yeah,
Jabari,
no problem.
what would you need?
Yeah, we can talk together, Jabari, per email, or we can call each other.
Or you just update a slide in the presentation and I'll see it.
Yeah, okay.
Okay.
Yeah, awesome. Thanks, Jabari, for working on the project update slides, and I think we'll get the material in so you can put the draft in by next week. We have about 9 minutes left. Does anyone have anything else they'd like to add or bring up?
Just I guess a question to the team. The last one. So I've gotten feedback that having redundant manifolds in a rack, particularly with a door heat exchanger. So in this case, it will be a red door heat exchanger with a cool plate. that if we have manifolds in a rack, that it's not a problem for airflow, redundant manifolds. And I just want to know, in your experience, with adding a second manifold, or two manifolds, I guess, if you have inlet and outlet separate, does that obstruct airflow? Does that create problems in terms of running hoses and stuff like that? Because I mean, I have no reference point. I've never seen it, in the field. Like two manifolds on a door heat exchanger, plus a CDU.
I don't know. Redundant manifolds, I don't see the advantage to use such also 4 manifolds in a rack. I don't know which is the advantage of that. For the second, for Open Rack V3, I think there are not space enough for everything. You can Open Rack is assembly. There are not too much place to connect everything if you put another 2 manifolds there. For the air could be a problem, but it's not a big issue. The problem will be more for the hoses, the connectors, and everything.
And then the loading force, right? The loading force, because now you have basically doubled up the engagement loads. So then now you need to check FEA, right? Is the rack stiff enough to accommodate an additional pair of manifolds, right? What about the chassis? Is the loading mechanism robust enough to overcome twice the amount of loading force, right? Because now the chassis has to slide in and engage twice the number of QCs. And to be honest, just adding 2 additional sets, an additional set of manifolds is going to add so much cost. The question is, what are you like? How does that cost compare to the cost of taking the rack going down, and what sort of failure rates are people anticipating on the manifolds, right? I think that's really
but the
important.
another question is, what is the benefit? Which is the cost and benefit, this relationship? And the benefits are, I think, 0, because if you have a leakage in the manifold or something, you have to shut down the system.
Yeah, or the assumption is that you have some way of isolating the leaking manifold and then transition primarily to the redundant pair. But that's just, oh man, that sounds so complicated. But I mean, is Jabari, maybe you can provide some background on this question. Did this come up in concurrent ability, or?
Yeah, it came up in that meeting. Yeah, Uptime was basically saying that they've been seeing redundant manifolds being applied without any problems. Now, I don't know if that is specific to cold plate, or maybe some sort of chassis immersion solution. But I didn't have anyone on the call with me at the time who could say, well, listen, here are all the things that are, now this wasn't the bi-weekly call. This was a call that we did separately for the summit. That's what I mean. So there was just me and I think John Gross on the call. And yeah, I didn't have anyone to say, well, these are all the issues specifically with rear door, and there are redundant manifolds. So I'll take this feedback and give it to Uptime. Because I think they're drawing kind of a line in the sand there.
Yeah, I mean, I don't think redundant manifold should be a requirement, but it could be a suggestion, right? Which is, hey, this is something that's been done, but my assumption would be is that the application of that would be very specific, right? There's a specific type of user who would do that, but to do it at scale, I think that would be incredibly costly.
Yeah.
Yeah.
Okay. All right. Thanks, guys. Appreciate it.
Yeah. No worries. Interesting. That was an interesting question. Okay. So we're almost at time. If there are no further comments or questions, I'm happy to give 4 minutes back. Thanks all.
Yeah.
Thanks, guys.
Yep.
Thank you, you too. Bye bye.
Thank
Good day,
you.
everybody.
Bye bye.